Those of you watching on Udemy course, what you will have access to is a refactored version of this feature engineering pipeline that contains everything that we've seen so far, but that makes sure that it's scripted in a way that's more convenient to read and grow. And so don't worry too much about what you see here for now. Just looking at the pipeline itself, you will see that there is like all the components that we had in the notebook, but refactored neatly into a script. And we have defined here a custom feature building object that is going to be our pipeline with a chaining pattern that allows us to run all of the functions that we've seen to go from the raw sample data to the clean features in a neat way. So you will see that these patterns basically implements each method by returning the object itself at the end. And what it allows us to do is it allows us to compile all of this pipeline in this very neat and convenient, let's say, pattern here that applies each of the methods one after the other, or like in a chain way, hence the name, so that it's more easier to maintain and to manage it. Now, what you also will have access to with this script is a set of unit testing more extensive, let's say, than what we've seen in the notebook. You will see that we test a bunch of methods that are useful for us to understand. And you will see that we follow exactly the structure that we have defined earlier, which is define all of the inputs that you need, right? Run the methods or like run the functions that you want to test, and then define all of the outputs that you should get out of this, right? And we're going to follow this pattern every time we want to run a unit test. Now, the last thing that you're going to have access to as well is you're going to get access to a suite. You're going to get access to a suite of integration tests as well. This is much more advanced topics, and you're going to need to read a little bit on the subject to understand what's going on, especially with like fixtures and things like this. But essentially what you're going to have in here is a practical implementation of more advanced integration testing, which doesn't just implement like unit functional tests like we've seen, but that really shows you how to apply the interaction between different modules together, which is really what integration testing is concerned with. So the big question now becomes, how do we want to take our code that we put into the notebook, and how do we want to refactor this code so that we achieve two goals? First of all, we make it easy for people to understand what's going on in our feature engineering pipeline. We want them to understand clearly the different steps that we have taken to go from the raw data to the completely clean features, right? So that's the first objective. And the second objective is going to be to make sure that we can build an efficient and like well laid out testing suite on top of this code. And when I talk about testing suite, I talk about the unit test that we've already discussed briefly and the integration test that we're going to see in a bit more detail. And so all in all, like to really get to this point where we have these two objectives complete, what we're going to do is we're going to set up a custom class. This is exactly where the power of object programming, this is exactly where the power of OOP comes in, right? Because you can set up some pretty decent code that's, let's say, not too bad in terms of code leaks and things like this. Let's say some decent state-based code that don't really have pure functional patterns, but you can still preserve a very good structure so that you're going to achieve the code quality and the unit testing and the integration testing in the long run. And so that's exactly what our custom feature builder is going to do here. First of all, we're going to make sure that we instantiate at the beginning all the data sets that many of our functional units are going to need. And we want our functional unit to be as scoped in as possible. In other words, we want to minimize the amount of code leaks or change in state that our functional unit do. We want our functional unit to get some input, apply something on this input, and return some output. We don't want the functional unit to do anything else than that. That's the best way to avoid code smells and things like this and end up with like crazy crazy spaghetti code in the long run. We want this functional unit to be as simple as possible. And incidentally, if we keep this functional unit very, very simple like this, input, output, then we're going to nicely be able to unit test on them. And we're nicely going to be able to put them together within an integration test and have everything verified end to end. So that's why here, first of all, we make sure that we provide all of the things that our functional units are going to need. And we're going to make sure that the functional unit, instead of returning some data frame output, it just returns the class itself, like the custom feature itself. And the reason for that is that if you return the custom feature itself, the custom feature builder instance, instead of pandas data frame, what you can do is that you can start concatenating a bunch, or like chaining a bunch of operations that we apply on these data frames. And this is exactly what we want, because if we have this nice chain, we're going to be able to do very, very quickly some useful testing afterwards on it. So what you're going to find in this custom feature builder is a bunch of methods that have been built from the functional units, functions that we had from the notebook. And the only difference really here is that preserve the state of the feature df, so that we minimize the amount of code repetition that we had across the different functions. And you will see that these are all the functions that we've seen, let's say, in the notebook before, so I'm not going to spend too much time on them. But the very big kind of like difference here is that we end up with this runner here, this run processing pipeline, which contains all of these functional units put together into this chained pattern. And that is exactly what we need so that we can have the unit testing that we're going to do right now individually on each one of these functions, and the integration testing that we're going to run on this processing pipeline. And that's going to make sure that things run end to end. All right, so now that we understand the reason thinking that was put into coming up with this pattern for the custom feature builder, now you will understand why this makes it so convenient for testing. So if you head over to the test, what we will see in the test is, first of all, the unit testing, and second of all, the integration testing. So we're going to focus first on the unit testing, and this should not come as a surprise that we follow exactly the same pattern that we have defined in the notebook. In other words, what we do here is we are going to define a lot of inputs, like inputs that we need to provide to our functions, and outputs so that we can verify that the pattern, get some input, provide it to the function, get some output, and verify that the output is exactly what you would have expected by applying the functional unit on this data holds true, right? So that's exactly what you're going to see in this file, a bunch of fixtures that define the inputs. And we also kind of like create our custom feature builder so that we can access all of the methods that it has defined within it, and so we can test all of these methods. We have the synthetic df, we have the feature df. These are going to be fixture input as well into the custom feature so that we can apply each of these functions and check that the output is correct. And then we can get started. Like essentially we have like a few methods. So I'm going to go back to the test that we had written for the feature bullet points, which is the one that we know. And I'm going to let you guys do other test methods so that you can really test that you have an understanding of what's going on. But essentially what we do here is we do a very similar, let's say, pattern or like structure than we did in the notebook. The only difference is that we're going to use what is called a mocker. A mocker comes directly from this Pytest testing suite. It's a very convenient utility that's going to come for us. You can definitely check the documentation to understand what I'm talking about here, but essentially what Pytest does is that, first of all, it allows us to define exactly the fixture, and we're going to be able to access these fixtures or this synthetic input data directly into the unit test that we define. That's going to be like a very, very convenient, as you're going to see. And second of all, from Pytest, we're going to have this mocker object that allows us to mock everything we don't need about the test and focus exactly on what we want to test, right? And this is what you're going to see here in this unit test. So here what we do essentially is, again, for our total BR points and to make sure that it works correctly, we provide a mocker, we provide a custom feature builder and a feature df. And if you're wondering where these two inputs come from, well, they're exactly coming from the fixtures that we have defined, so that we can focus on what we really want to test and not really focus on having to work with a custom feature builder. We're just going to mock this guy so that we don't really have to worry about how it works and what kind of things he does and like anything like that. So you will see what I mean here. Let's start first of all by creating our input data. So our input data is just going to be features df where we don't keep the total BR points. And the reason for that is that we precisely want to apply some processing on this input data to generate these total BR points. So what we're going to do is we're going to drop this total BR point from the feature df. That's going to be our input data. And then we're going to do the same to generate the output, right? Like the output here is going to be the same feature df where we keep these total BR points, but we drop some other stuff that we don't really need. And precisely what we want to do is we want to see that by applying some processing on this intermediate df, we get to this needed output of a feature df. And this is exactly what our test is all about here. So essentially what we're going to do here is that we are going to instantiate our custom feature builder. Remember, our custom feature builder, it's just an instance of this pipeline that we have so that we can use it however we want. And the reason we need this in the first place is that we need to be able to access inside of the custom features builder, we need to be able to access the processing, the method that we want to test, right? And the only way to access it is by using this custom feature builder. So we take this custom feature builder, we're going to provide this intermediate df, so that's going to be the data frame that it needs here, and we're going to provide only this data frame because if you think about it, that's the only data frame, like this feature df, that is the only data frame that our feature total BR points need so that it can generate the total BR points, right? You can see that the operations are just based on this one features df data frame. Everything else, like the tick data, the merge data, like all of this stuff we don't really need to be able to see that our function works correctly. And that is exactly why here when we create our custom feature builder, instead of providing it everything, all the parameters, all the data that it usually requires, instead of doing that, what we do is that we just provide it with the intermediate df, which is the feature df, and we just mock all the rest. We just give it like some random piece of crap that it's not going to really use or that it's not really going to need. And once we have done that, what we can do is we can really focus on making sure we apply the feature total BR points and we get back the feature df. So that's what we get out after we have applied this method. And as always, what we want to do is we want to test that, our process output, what we have generated from running the feature total BR points on top of some kind of input, that is exactly similar to what we expect as an output, right? This is exactly what our unit testing is focused on. And you will see by running this is that we're going to get exactly to this point where the two things are equal. And this unit test is therefore going to work correctly. And that's exactly what we needed in the first place. Now, once you have done this kind of thing for all of the methods that we have a proper unit testing suite, and we can run it with Pytest. How to invoke Pytest testing, blah, blah, blah. So you can do it like pretty much like any way you want. All right, so now that we have defined the unit test suite, what we can do is we can head over to the terminal and we can just run the test suite by running Pytest, providing some kind of coverage report that's going to tell us like, hey, how much coverage do we have for MLOps? Like basically out of the whole code base that we have, how much of the code do we have covered and protected by unit test? And we're going to just say like, run this test on all of the MLOps tests that have been created and check out the report and things like this. And then afterwards, we're going to be able to do a bunch of cool things. What we've created in terms of coverage report, we're going to be able to create like an HTML report so that we can visualize, let's say, what part of the code base is covered by the test. So before anything, what we're going to do is we're going to jump into the test model feature end-to-end, right? And this is going to be part of our integrating testing suite. And you will see here that again, as a set of fixtures that we're going to need to be able to test this end to end, we're going to create our custom feature builder. So we're going to create a, let's say, like a utility that allows us to access our custom feature builder for the same reason as before, so that we can access its underlying methods. And we're going to create as an input, as a fixture, we're going to create a data frame that contains basically what we would need to provide to custom feature builder so that we can run the pipeline, like this synthetic data that we base a lot of operations on. And so we're going to create this synthetic DF that contains all of the columns that it needs. And then we're going to create the feature DF as well, because again, this guy here is going to be provided to the custom feature builder as an input on which we can apply stuff. We're also going to be using this as an output, because at the end of the day, what we get out of this merged data contains a bunch of data from feature DF and from synthetic DF. So once we have defined like the two inputs fixtures that we need, now we can do something like this. We can do something like test that the custom feature builder works correctly. And that is exactly why this is an integration testing rather than a unit testing. What we test here is a whole utility. It's like a whole thing that contains a lot of different sub-processing units, right? We don't make sure that everything works, like all of its parts work individually. We make sure that this runs end-to-end, that the integration between all of these sub-processing units work correctly. And that's exactly why we're cataloging this as an integration test. If you had like a bunch of different classes like this one that use each other or like interact with each other. So for instance, you would read from some kind of API class, you would do some kind of other stuff here. You would again have this interplay between different utilities, and so you would therefore have more testing in the integration test to do. But for now, let's just focus on this one thing here. Let's just make sure that when you run the whole processing pipeline, that you get what you want out of this, right? That you give the correct inputs, the synthetic data and the feature data, and that you get this kind of like correct merge data out of that. And that is exactly what we want to do here. We again define a mocker, right? And you will see that later. So we're going to create a mocker to ensure that the right methods are being called. Essentially, what you have to think about is in one way is we want to abstract all the utility of the methods. We don't really care in the integration testing. We don't really care that all the sub-processing units work correctly. This is already established in the unit testing. So we don't really need to check that, this method does something correct. We already know that it does something correct because we've already unit tested it. So that's why we mock each of these individual methods that we have in our custom pipeline. We just mock them because we just know that their utility works properly. So we just mock them here. And we just say like, you know what? If they are being called, like if one of these functions is being called, just return a value that's also, like some kind of mocked value, right? Because again, we don't really care about making sure that it returns something correct. We've already established that in the unit testing suite. And so we just mock a bunch of things, right? And we run the pipeline. And when we run the pipeline, if you think about it, again, we don't really want to make sure that when you run the pipeline calls a bunch of methods that work. We already know that these guys work. The only thing that we're interested in here is that it correctly calls the right method. It correctly makes use of the right functional units, and it correctly applies them on this, let's say, input data that is provided to the custom feature builder. And that is why in the integration testing, what you have essentially is one call, like one run processing pipeline on this mock builder, this magic mock builder. And the only thing that we test, let's say, in this custom feature builder works correctly is that all of the underlying methods that are part of this custom feature builder are correctly called as many times as they need to be called. That's exactly what we're interested in here. So that's why we put a bunch of assert called once, assert called once, assert called once. When you run the processing pipeline here, what you have here is a bunch of methods that should be called once in a chained way so that you can have the processing that you need. And so this test here should be good. Now the second test here, test run process pipeline work correctly. So now this is pretty different. Here we just wanted to make sure that the custom feature builder worked correctly. Now we're going to make sure that the process pipeline works correctly. So now that we've tested that, when you run the processing pipeline, you have access to all of the right methods that you need. Now we're going to test that when you run the process pipeline and you provide it some kind of input, it provides you the right output. And again, we don't really care about all the individual functional units of this integration testing. We just care that when we provide it a synthetic DF and a feature DF, what we get out of that is basically the merge DF that contains everything, right? And the way that we're going to test this is, well, again, we're going to use these very convenient fixtures that we have defined here. So we have defined a fixture that's returning this DF. We have another one here that's returning that DF, the feature DF. And so together, like if we provide this custom feature builder to this run processing pipeline, and this custom feature builder is composed of the synthetic and intermediate data. Well, this is exactly the same pattern as what we would do in real life here. We would run this processing pipeline on the custom feature builder, and the custom feature builder is just basically something that contains the two data frames of reference. So what we get here in terms of processing output, we just need to make sure that what we get there is basically equal. That's what we're using, pandas testing assert equal frame. We want to make sure that this processing output is equal to this feature DF, which is the one that we've defined, right? We have defined this one here as a fixture. It's kind of like an input and an output because we know that the output should be exactly what we see in here. So we check that the processed output is equal to this feature DF. And if it is, then we know that, when we run the processing pipeline on a specific set of inputs, then we know that what we get out of that is correct. And so we know that our integration test works, and we know that the code base is safe then. All right, one subject that I wanted to bring up before we move on to running those tests that we've written here to make sure that everything works is the topic of Docker. This is something we're going to need to be able to run this test in the first place. So let's first of all try to understand, why do we need Docker in the first place? What does it do and how does it work? So first of all, why do we need Docker? When we run tests, what we want to make sure is that somebody else working on another machine, on his own computer or somewhere else, trying to run these tests, is going to achieve the same outcome as what we have when we run the test on our local machine. So what we want to have essentially is a local environment that is replicable, that contains all of the dependencies that you can think of. The Python libraries like sklearn, pandas, numpy, like all of these dependencies on which your code depends. You want to have that package together so that the tests run in a completely similar way regardless of where it's being run. And that is the reason why we want Docker in the first place. Now, if you've been working a little bit on this kind of stuff before, or if you followed like the first steps of this course, which was related to setup, you might be wondering, but Sean, why don't we use the Conda environment that we have set up at the beginning to be able to do that? This is actually quite similar to the problem that Conda or Mini Conda or Anaconda, whatever you want to call it. This is exactly what this was trying to solve. It was trying to set up a virtual environment so that you would run your code, your Python code, in an isolated environment, and so that people could be sure that they would be able to run it in completely separate runtimes. Now, if you're wondering that, you're completely right to realize that for this specific use case, just running this test in a specialized environment, Conda and Docker achieve exactly the same purpose. They both allow you to do that. So they're very similar in that sense. But Docker just goes further in the development, like the whole software engineering cycle, by actually allowing you to package completely all of your applications, but with the source code, with the dependencies, like all of this stuff all together, so that you can scale up application quite a lot and quite fast. Now, it's really hard to explain this without getting very, very technical and give more details on that. So I would really suggest that you go maybe look into, Docker introduction, Docker getting started, like this whole thing, if you're interested to understand better what I mean by usage of Docker. But for here, at least, I want to expose you to the base, the 101 of Docker, so that you understand why it helps us to run this test and how it can be useful later on. So now moving on to the second part, how do you package your code inside of your Docker containers, your Docker environment, so that you can run this test? And if anybody has access to this Docker packaging, they would be able to run this test exactly in the same way in a completely different environment, in another computer, for instance. Now, the way that you do that is with two files. The two files that you see here. First of all, a Dockerfile. Let's think of it as a recipe for packaging your code to run in this specialized environment. And then a Docker Compose file, which is an orchestrator that's going to take this Docker file and convert it into a runtime environment so that it coordinates multiple Docker containers. Now that might sound very confusing, so let me get in a little bit more details and we're going to see how this is useful. So first of all, what we're going to do is to be able to run this test, we're going to specify in our Docker packaging that we want to have Python installed, let's say, inside of this environment. And this is very similar to what we did with Anaconda. We started Anaconda, or we created our Anaconda environment by just saying like, hey, make sure that you have access to Python 3 in this environment. This is just a way to make sure that we're going to be able to run these scripts. And then the second step that we're going to do, and you see why I'm calling this a template or a recipe, it's just because we're really like specifying a bunch of steps that is going to instruct Docker how to create our packaging of our dependencies. And so the second step of this recipe is just going to say like, hey, when you're done downloading Python and everything is working, just move on to like creating a, let's say like a folder, a repository that is called Bolot. Actually, maybe I should call that MLOps, but let's call it like Bolot because it's based on this game. And now that I have this repository created inside of my container, inside of my virtual environment, I can say, make this container like the root repository where things happen. Just make this like the basic repository that I access when I go inside of this environment. And then we move on to putting a bunch of credentials that we're going to need later for all of the Google Labs that we're going to see together. We're always going to need some kind of credentials to be able to log onto the Google Cloud Platform. So I'm just going to go ahead and take these credentials from my local computer. Don't worry about this too much for now. You're going to have a lab that's going to show you how to generate these credentials in the first place. But essentially what I'm doing here is I'm taking these credentials and I'm putting them inside of a credential folder that is spawned out of this root repository called Bolot. And that's where I'm placing them. And then I'm copying all of the requirements of these projects, and I'm putting them from our local machine to the container, to the virtual environment where it's going to be. And I know this might sound very, very conceptual because you might be wondering like, wait a second. So I'm taking a file and I'm putting it somewhere. Like, where is it that I'm putting it? Well, the answer is that you're still keeping this file in your local file system, like on your computer, but you're putting it inside of a virtual environment that lives on top of this local file system. So this file still exists. Let's say it's not going to leave your local environment. You're still going to have access to this file, but it's just going to live in this environment where you can package your stuff so that you can run things in isolation. And so finally, we're going to say like, hey, you have access to this requirement file. Just install everything that you see in these requirement files. And again, this is very similar to what you would do in Conda. You would install all of these requirements on Conda so that you could have access to them at runtime when you want to run your Python scripts. So this is exactly what we do here. And then let's say like the two final steps are pretty straightforward. The first one is make sure that the Python path recognizes or at least can locate this source folder, the source repository, where all of the scripts live. This is where all of the stuff related to your machine learning engineering course is supposed to be, right? So essentially what we're saying is that when we're placing the machine learning engineering course in a folder called source, we just want to make sure that the Python path can point to this and that Python, the local interpreter that's going to be in the container, the Python interpreter, can have access to the modules that are defined inside of source. In other words, just to recap, this might need to be changed if you decide to name this folder differently, if you decide to put like all of your MLOps stuff coming from this course inside of a folder called MLOps, you might need to name it differently. But I'm going to show you it's going to be related to what we do here in the Docker Compose. So stick with me on this. Don't worry too much. Just keep in mind for now that what we do here is we're telling the Python interpreter that it needs to have access to the Python modules, to the Python packages that we've written together. So for instance, the unit test, it can find it inside of this source folder that lives in the container. And then finally, we specify a command that's going to be, let's say, what happens when we try to enter this Docker container, when we try to enter this environment where things live, where our code live, where our dependency live. It's going to just spin up a bash script, like just a shell like this one here, that's going to allow us to work in this container. And you're going to see that very soon. So that's the outline, that's the skeleton of the Dockerfile. Now let's move on to the Docker Compose part. This is the orchestrator. This is the script that's going to trigger this Dockerfile to get constructed, to get built, and that's going to give us access to this Dockerfile in the first place. So what do we put in this file here? We put a bunch of specification, a bunch of instructions on how we want things to run. First of all, we're just going to use a specific Docker Compose version called 3.7. This is probably not the latest because I started this tutorial a long time ago, so this probably has evolved over time, but that should be enough for now. And then we specify the services, the containers that should be living, that should be existing for us to work with. And we're going to create one that's going to be called bullet testing. And that's literally going to be the container that we use to run tests. That's where we want things to run when we talk about testing. Well, we're going to just name the image. You're going to see what I'm talking about when I talk about the image. We're going to name the image bullet testing. Essentially what we're talking about here is the template of this Dockerfile. The container template that is associated with this Dockerfile is going to be named bullet testing. The container name, so the instantiation of this template, like an actual instance that's launched from this template, is going to be named bullet testing as well. I'm not very original on the naming, but you'll see that it's going to make sense in a second. We're just going to say a few things like, hey, by the way, when there is a failure, maybe something doesn't work, maybe I made a mistake, like a typo, or maybe, I don't know, there is a library that doesn't exist in there because it's deprecated. When something goes wrong, whatever it is, just make sure that you just try a little bit more again before you just call it a day and move on. So that's what we're saying here, just try to restart things. And by the way, again, this is the orchestrator that launches, triggers the creation of this environment. You would create a conda environment. And so what we have here is a build parameter here that says hey, starting from the root path, from where you are physically located as a file, go ahead and look for a file named Dockerfile. This is the template that you need to create this isolated environment. And now we're reaching the most important part. We're reaching what is called the volume. The volume is essentially a way to say that the local files that we have on our local host, on our computer, all of these local files that exist in here, I want all of these files to be available inside of the bullet folder that I created in my environment. Now you can see the connection between the creation of our directory here called bullet and the orchestration step that tells us hey, grab all of the stuff that you can see in the actual real environment where files are physically located and put them inside of this virtual directory that is called bullet and that lives inside of this Docker container. This is not very important. This is not very important either. These are some few specifications that you can definitely look and try to understand if you get into the Docker documentation. But what's pretty important is that we're going to use a local driver of our volumes. Well, it's pretty important. It's pretty technical, so I wouldn't want to spend too much time on this either. And we're going to create a network. This is basically the network that we're going to be using to connect a bunch of different containers together. Again, this is getting very technical and not necessarily for our purpose. So let's just stay fit for purpose right now. And let's realize that with this, we have one service that is defined. That's our service. It tells us how to launch this Dockerfile, how to create this environment. And it's going to be enough for us to be able to run things in this protected environment. Now, this is exactly what we're going to be doing. What we're going to be doing now is we are going to look at the images that we have available for creation, for instantiation of our environment. So we're going to do a Docker images, and we're going to see that one of the images that I have here is the bullet testing. So I already have it running because I already created it. If you don't have it yet, you will not see this appear here. So the first time that you run Docker images, you are not going to be seeing that here. But essentially, this image is this template that tells us how to build the environment. But it's not the environment in itself. The environment in itself would be in here. The environment in itself would be seen if you did Docker PS, and you can see that I don't have any environment, any instantiation of these templates running. I don't have any containers that are up and running that are based on this Belot testing image. So that is the first thing that we're going to do. The first thing that we're going to do is we're going to clear this, and we're going to do a Docker compose up, and we're going to launch Belot testing. All right, so this is exactly what we need. We need to launch Belot testing so that we can run the test in this environment. And we can see that, well, because I already have launched it before, it's pretty straightforward. For you, it might take a bit more time. Don't worry too much if it takes some time, because essentially, because I've launched it already, I have all of the libraries, like all of this stuff is already in my computer. For you, what it's going to do is it's going to fetch this library and download them. It might take a bit more time. But essentially, you should reach this point where you have the container running. It's been created. And what we can do now is we can inspect this container. Again, a container is just another name for a virtual environment where you can run things in a safe way. So what we can do is we can create a new shell, and we can do something like Docker exec it Belot testing, and then we're gonna launch bin bash inside of this. What am I doing here? What I'm doing here is I am saying, hey, you know this container that is called Belot testing that I just created? Just go into it, go into this virtual environment and create a shell, just an interactive shell that is gonna be allowing me to interact with what's inside of this container. And if you're familiar with virtual servers, we're gonna get into that actually in this course, but if you're familiar, if you've ever SSH'd in a virtual server on the cloud, this is very similar to what we're doing here. We're just like SSHing inside of our container, and now when we look around and we look at where we realize that we are in this virtual server that is allowing us to run things in an isolated way. So what are things that we want to run? Well, things that we want to run are, for instance, these tests that are going to be in MLOps. That's the whole point of exercise, is that we're going to create this container, we're going to head over to the tests that are in MLOps, and we're going to launch this test exactly in the way that we would do if we were running things in our local computer, not in this environment. We are going to run this test by running the Pytest command, and it's going to make sure that this test can be run whether you run it on your computer or whether somebody run it anywhere else with their own computers. Up to you guys. Now that we have an understanding of the way that this unit testing suite and integration testing suite have been built, we can go ahead and kind of like run them and see what's happening here. So first of all, we're going to go over the testing suite, and we're going to grab this code to run the test, right? So essentially what we're going to do is we're going to go to the terminal, and we're going to run this Pytest with a bunch of arguments, with these coverage arguments. Okay, so we're going to grab this Pytest and we're going to run it and see whether our testing suite has worked. Okay, so we're going to grab this code here and we're going to run our test and see whether our testing suite has been built successfully. And so when you grab this and you run the test, you see that you get out quite a few, let's say, insights from the run. First of all, Pytest is going to tell you like, okay, here are all the tests that have been run. We have basically like the list of all the tests we have defined in the two module, the unit testing suite and the integration testing suite. And we can see that we have passed basically all of these tests, right? We have gone through all of them. We have them nailed down. And the most interesting thing about running the test is, well, it's not just knowing that you've passed the test. So passing the test is great, right? In fact, when you have all of these checks that are green like this, you know that your code is in a good state, and so you know that you can push whatever feature you've been working on. Like, you know that you have created a new feature that is not fundamentally gonna alter the state of the code base for other people. It's not gonna impact like the stuff that they've been doing, and because you have it correctly working, you can incrementally build the stuff that you've been working on. And so this is the great validation that we need to safely push new code on our code base. But what's very interesting here is to look at precisely what has been tested, right? And this is exactly where the coverage report is so important for us. It tells us like, okay, out of all the modules that have been behind this testing, this is the breakdown of what were kind of like tested, what was kind of missed, what code was not considered in the test, and how much, some kind of estimation of how much coverage your test has on this module. And so we can see that, for instance, we are definitely not testing anything coming out of the best practice file. With our test, we're just not covering any code that has been defined in there. But we are testing quite a lot of code that is present in the model feature file. And this is logic, right? Because if you think about it, the two testing suite that we have defined, the unit test and the integration test, were really built with the model feature in mind. Like what we had in mind was to really make sure that our feature engineering pipeline was working properly. So this is where we've been putting most of our attention. And this is where we were hoping to have quite a high amount of coverage in terms of how much code is like secured with the unit testing. And 78%, although it's not perfect, like although it's basically not all the code, it's a fair chunk of the code present in there that is tested and clean with our testing suite. So I'm pretty happy about this. We also have all of the code coming from the cleaning module that is completely tested. And we have tests that doesn't make a lot of sense. Like it should actually be excluded from this. Like if you put actually your testing module out of the scope of this run, then it's not going to come out of this, right? So that's not very important. If you look at the overall statistic usage of your testing suite, you get to an estimation of how much of your code base is tested. And that's usually what people report on their GitHub profile and things like this. Like they want to tell you like, hey, I'm building this code base and everything is tested and everything works correctly. So it kind of gives you like an amount of credibility to your project. And if you're working in a big team, you definitely want to pump these number ups because you want to make sure that, when you write new code, you don't fundamentally change the code that other people have written.